Today I am going to discuss the digital signal processing EEE or PC-EEE 801 Group B 5 marks questions. Question number 2. What is discrete time systems? Write the various classification of discrete time systems. What is discrete time systems? There are basically two types of system. One is continuous time system and the second one is discrete time system. Discrete time system is a device or algorithm. It is a device or algorithm that operates on a discrete time signal for the input or excitation. According to some well-defined rule, to produce another discrete time signal for the output or the response of the systems. The diagrammatic representation of a discrete time system is shown below. Here is the diagrammatic representation of a discrete time system, that is a block denotes the discrete time systems. Here is the input x of n or excitation of the systems, and here is the output or response of the systems. After some mathematical operations, we will get the output response of the systems. Now, classification of DTS or discrete time systems. The discrete time systems are classified based on their characteristics. Some of them are statics and dynamic system. The first one is statics, that is also called the stationary systems, and dynamic systems. Second one, the most important one, that is our time invariant and time variant systems. Third one, linear systems and non-linear systems. Fourth one, causal and non-causal systems. Fifth one, stable and unstable systems. Sixth one, FIR and IIR system. FIR, finite impulse response systems, and IIR, infinite impulse response systems. And the last one, that is recursive and non-recursive systems. This is the answer of the question of first question. What is discrete time systems and their various classifications. Next question, question number 3. State and prove the time shifting property of Z transform. The statement, we have to write the statement of the time shifting property and prove that. The statement of the time shifting property is here. The shifting property of Z transform states that Z transform is a shifted signal. Z transform of a shifted signal shifted by n units, either right side or left side, shifted by n units of time is obtained by multiplying z to the power n or z to the power minus n to a z transform unshifted signal. Just we have to multiply z to the power n or z to the power minus n with unshifted signal x of z. Let a signal x of n whose z transform is x of z. X of n is the signal whose z transform is x of z. Now by shifting property, we can write z of n minus n, that is right shifted, and z of n plus n, that is a left shifted signal. In case of a right shifted signal, it will be z to the power minus n into x of z and in case of a left shifted signal, it will be z to the power n x of z. Now we have to prove this one. By definition of Z transform, we know that x of z equal to z of x of n that is the given signal, and its Z transform denotes summation n equal to minus infinity to plus infinity x of n into z to the power minus n. That is the definition of the Z transform. From the definition of the Z transform, we can write z of x n minus n, that is a right shifted signal, summation n equal to minus infinity to plus infinity x of n minus m into z to the power minus n. Here x of n, in place of x of n, here the signal is x of n minus m. Just n unit shifted to the right. Now let n minus n equal to p. So n equal to p plus n. In place of x of n minus n, we put x of p and z to the power minus n plus p. In place of n, we can write p plus n. Now we have to change the limit. When x tends to minus infinity, p tends to minus infinity, and x tends to plus infinity, p tends to plus infinity. So the limit, as it is same of the previous one, summation p equal to minus infinity to plus infinity x of p z to the power minus of n plus p. Now just calculate this one. Summation p equal to minus infinity to plus infinity x of p z to the power minus n and z to the power minus p. It is the limit is here, the limit is only p minus infinity to plus infinity. So z of x to the power minus n is there, and now summation p equal to minus infinity to plus infinity x of p z to the power minus n. Now in place of p, if we write n, then we will get this one, summation n equal to minus infinity to plus infinity x of n z to the power n. This is the Z transform of x of n, and it is defined by x of z. So z to the power minus n into x of z, that is the proof of shifting property of Z transform in the case of a right shifted signal. In the same way, we can prove for a left shifted signal z to the power n into x of z. That is for left shifted. That is for left shifted